In our previous video, we took a look at how we could graph quadratic functions based on where the vertex was in the vertex form. Now, when the exponent is higher, we have a polynomial, and the graphing is a little more complicated. And so in this video, we're going to take a look at how we can graph polynomial functions, specifically when they are in factored form. And when I say they're in factored form, the function is going to look something like f of x equals some number times x minus, I'll call it r1, times x minus r2, times, you're just going to see it all the way down, times x minus the very last r. So a whole bunch of factors multiplied together. What I want to start off with is how to find all the pieces of the graph, and then we'll look at an example of how we can use those pieces on a real problem to build the graph. So when we're looking at graphing a polynomial, the first thing we want to graph is the y-intercept. And the y-intercept is found quickly by making x equal to 0 and solving for your f of 0, basically. And that'll give you a number that's your y-intercept. The second thing we'll find is the x-intercepts. Now with the x-intercepts, what we're going to do officially is we're going to make the entire f of x equation equal to 0, which really means we're going to look at the individual factors. Because remember, we saw in our previous video that if things are multiplied together and equal 0, each of the individual factors must be equal to 0. So what we'll really do here is set each factor to 0. And solve what's left. The third thing we're going to do is identify the multiplicity of each x-intercept. At least for the sake of our class, one of three things is going to happen at the root, which we're going to call r here. At the 0, at the x-intercept. The first option is if the factor that built that x-intercept is just something like x minus r, we're going to see a straight line through that point. And it might go up or it might go down, but it's just going to go straight through that point. Now, if our factor x minus r is squared, we're going to say what it's going to do is it's going to bounce at that point. And it could bounce up or it could bounce down, but it's not going to cross that point. It's going to bounce at that point. If we've got a cubed power, we're going to say it levels off at that point. And it might come in from the bottom or the top. It doesn't matter which direction it comes in from, just like the others. But what you're going to see is this leveling out motion at the root. Finally, the last thing we can look at is the end behavior of the graph. And the end behavior we can find by multiplying out all the x terms. And we'll look at what that looks like in our example. And you might remember that you've kind of got one of four options. If you've got a positive and an even exponent, it's going to go off to negative, or it's going to go off to positive infinity on both the right and the left side. If the term is negative and it's got an even power, then it's just the opposite. It goes off to negative infinity on both the left and right side. If it's positive and odd, positive coefficient, odd exponent, you're going to see it come in, maybe wiggle and go out, but it goes to negative infinity on the left and positive infinity on the right. If it's negative and odd, it's going to come in from the top, wiggle and go down. So it goes to positive infinity on the left and negative infinity on the right. And we've seen that prior when we were just introducing these polynomial functions. So those are the pieces we're going to look for. Let's take a look at an example where we can see it actually work out. So we're going to do some examples. And first we're going to start by graphing f of x equals -2 times x minus 1 cubed times x plus 2 squared times x minus 3. And we're going to start off with finding the y-intercept. Remember, to find the y-intercept, all I need to do is make each of the x's equal to 0. I find f of 0, which is going to be -2 times, when the x is 0, I get 0 minus 1, which is -1 cubed, times the x is 0, 0 plus 2 is 2 squared, times, again the x is 0, 0 minus 3 is -3. And so all I need to do is simplify this. -1 cubed is -1, 2 squared is 4, times -3. 2 times 1 is 2, times 4 is 8, 8 times 3 is 24. And since there's 3 negatives, I know it's negative. So my y-intercept is y equals -24. I then can find my x-intercepts by looking at each factor and setting each factor equal to 0. So we've got x minus 1, set that equal to 0. There's x plus 2, set that equal to 0. And there's x minus 3, set that equal to 0. Solving these three equations will give me my 3 x-intercepts. Add 1 to both sides and x equals 1. Subtract 2 from both sides and x equals -2. Add 3 to both sides and x equals 3. Those are my 3 x-intercepts. Now when we look for the multiplicity, what I see is the 1, the x minus 1 factor, was cubed. Because it's cubed, I would expect this x equals 1 to level off. The x plus 2 factor was squared, so that second one is going to bounce because it was squared as a factor. The x minus 3 did not have an exponent, or an exponent of 1, so it's going to be straight. The last thing I might be interested in is the end behavior. For the end behavior, we just multiply out all the x terms, and there's a number out front of -2. Don't forget that. So there's a -2. Then I'm just going to cube the x, square the x, and just take a regular x, dropping off all the extra numbers in the parentheses. So we've got the -2 out front, and all the x's with their exponents. That's going to give me -2x to the 3, 4, 5. There's 6 x's total there. And now I can see, because I've got an even exponent, it's either going to be a u or an upside down u. Because it's negative, I know it's not the upside up u, it's going to be the upside down u. So that means as x goes to -infinity, on the left side, I know the function's also going to -infinity. And as x goes to +infinity, on the right side, I know the whole thing goes to -infinity. So let's take all this information then and see if we can draw the graph. Okay, what I've done here is I've copied the information we had on our previous screen. So we knew the y-intercept is at -24. We know the x-intercepts are 1, leveling off, -2, bouncing, 3, straight. And then this brown little squiggly tells me I know I'm coming in from the bottom. It's going to wiggle somewhat and go out at the bottom because I know the end behavior. I don't know what the middle looks like. So if I start putting all this on here, I know the y-intercept's at -24. I know the x-intercepts are at 1, -2, and 3. I know at 1 it's going to level off. Let's put a little note in there. At -2 it's going to bounce. And at 3 it's going to go straight. Let's see if I can draw this connecting the dots, coming in from the bottom and going out of the bottom like we expect. Come in from the bottom to the first point and bounce. Go through the 24. The next point I should level off. And at the next point I should go straight through it. And sure enough, I'm going out the bottom like I expected. And now we've drawn the graph of our function. We can also go the other way though. I could start with the graph and see if we can build what the equation should look like. Let's try that as an example. So I'll draw my little graph here. And I want to draw points at -2, 0, at 0, 3, at 3, 0, at 5, 0, and at 7, 0. For this graph, I'm going to come in from the bottom, level out at the first point, go through the second point, bounce at the third point, and come through the fourth point, even though I missed by a little bit. It's supposed to go through that dot. We should be able to figure out the formula for this graph. One thing I can see is we have the y-intercept at y equals 3. I can also see there's x-intercepts in here at x equals -2. These are the x-intercepts. I'll label them in red here. X equals -2, x equals 3, x equals 5, and x equals 7. I can also see the first x-intercept at -2, it's leveled off. At the second one, at x equals 3, it goes straight through it. At x equals 5, it bounces. And at x equals 7, it goes straight through it. I can use this information to start to build the equation. We'll always start with f of x equals, and I always put an a out front because we need to figure out what that a is. It's really hard to tell just by looking at it, but we can find it fast enough. Then in factored form, I know each factor is going to be x minus the x-intercept. So if the first x-intercept is -2, x minus -2 becomes x plus 2. Then my next one's at x equals 3, so I'll do an x minus 3. X equals 5, I'll do an x minus 5. X equals 7, I'll do an x minus 7. Now we need to go back and put some exponents on it based on how the graph behaves, because this first one leveled off. So at x equals -2, the x plus 2 needs to be cubed to show that leveling off. At 5, the x minus 5, there was a bounce. To show the bounce, I need that one to be squared. That's going to give us everything about the equation except for the a out front. We find that a out front by using the y-intercept. At the y-intercept, we know the whole thing is equal to 3 when x is equal to 0. So I can find a, if x is 0, we have 0 plus 2 is 2 cubed. 0 minus 3 is -3. 0 minus 5 is -5 squared times -7. So 3 is equal to a times 2 cubed is 8 times -3 times positive 25 times -7. And if I were to multiply those all together, I think we get 4,200. So if I divide both sides by 4,200, A is equal to, let's see, I can reduce that fraction by dividing by 3, so 1 over 1400. So that means my function f of x is equal to a 1 over 1400 times x plus 2 cubed, because it has multiplicity 3 and levels off, times x minus 3 times x minus 5 squared, because it has multiplicity 2 and bounces, times x minus 7. And now I've got the equation of the graph by pulling off the important information from my polynomial. It's your turn to practice. Good luck on the assignment.